Now, when it comes to web services and pen testing, the issue that we have here is that the web services typically allow applications to expose interfaces that can actually be called by other applications. And the reason behind this is because they allow applications that are built on a wide variety of technologies to use the interfaces or to interact with each other's interface. Our primary culprit here is going to be XML, but it's not the only culprit. Now, typically web services are hosted on an internal network, but because of the increasing popularity of mobile applications and folks being able to gain access to these apps remotely, many web services are actually being exposed to the internet itself. So again, just to reiterate, because there's sometimes some confusions between web services and web applications. A web application is simply an application that is accessed through a browser, where a web service is a standardized way of establishing communications between web-based applications. And we do this because web services use HTTP and, as I mentioned before, XML. But other components can actually open up some additional attack vectors. Those components could include SOAP, which is our Simple Object Access Protocol, as well as WSDL, which is the Web Service Description Language, and UDDI, which is your Universal Description, Discovery, and Integration. So when you're doing a pen test with web services, you need to gather as much web service information as you can concerning your target. And we can accomplish this with tools like SOAP Lite, curl, or WS Chess. There's also some online tools such as UDDI Browser and WS Index that you can use to pull this information off. Our steps that we're going to use when it comes to web services will include starting off and looking for any WSDL entry points. And tools such as WS Digger, as well as Foundstone, has a great little product that can help you in looking or discovering those entry points. The next step that you would implement would then be to pass a malformed SOAP message to the XML parser, and attach a very large string to the message to see if we can perform an automated XML structure testing. Again, exposing to us what's available or what other web applications or connections we're making. We might be able to see information about SQL or XPath statements. We can also attempt to pass malicious information on the HTTP GET string that's associated to the XML application. The next thing we'd want to do is to test for what we refer to as a naughty SOAP attachment. I like to think of it as more of a dirty SOAP. Dirty attachment. Shame on you. This is the only image I could come up with. Now this is where we take a XML document, we build one up so that it has some malware as an attachment. And what we're doing is we're checking to see if the XML document has a SOAP attachment vulnerability associated to it. You could also attempt to resend a sniffed XML message using Wireshark or WebScarab to see if a replay attack could be implemented. You know, the longer I look at this picture, I keep wondering, is that a feather down towards the bottom, and did these pigs just eat a chicken? Which would actually save me a step when I'm preparing bacon-wrapped chicken.